In this video, you're going to learn about promises. Now, promises are available in JavaScript since ES6, although they have been around in third-party libraries for quite some time, but they finally made their way into the core JavaScript language, which is great because they're a really fantastic feature. Promises aim to solve a lot of the problems that come up when you have a lot of asynchronous code in your application. They make it a lot easier to manage your asynchronous computations, things like requesting data from a database, or in the case of the weather app, things like fetching data from a URL. Down below, we do a similar thing using callbacks. Here we have two callbacks, one that gets passed into geocode address and one that gets passed into getWeather. We use this to manage our asynchronous actions. In our case, it's things like fetching data from an API using an HTTP request. We can use promises in this example to make the code a lot nicer, and that's exactly what the aim is going to be a little later. For now, though, we're going to explore the very basics. I'm not going to compare and contrast callbacks versus promises just yet, because there's a lot more subtleties than can be described without knowing exactly how promises work. So what I'd like to do, before we even talk about why they're better, is go ahead and simply create some. Over inside of the playground folder, we're going to do that, and we're going to call this file promise.js. Before we define promises and talk about exactly how they work, I want to go ahead and just run through a simple example because I find that is the best way to learn just about anything. Going through an example and seeing how it works. We'll learn a little bit about how promises work, and we'll start to understand exactly why they're useful, why they've even come to exist inside of JavaScript. To get started, we're going to work through a very, very basic example. We're not going to do anything complex. We're going to stick to the core promise features. To get started with this very simple example, I'm going to make a variable called SumPromise. This is going to eventually store the promise object. We'll be calling various methods on this to do something with the promise. We're going to set the SumPromise variable equal to the return result from the constructor function for promises. We're going to use the new keyword to create a new instance of a promise. Then we're going to provide the thing we want to create a new instance of, promise with a capital P. Now this promise function, which is indeed a function, you have to call it like one, it takes one argument. This argument is going to be a function. I'm going to use an anonymous arrow function. And inside of here, we're going to do all of the asynchronous stuff we want to do. It's all going to be abstracted, kind of like we extract the HTTP request inside of this geocode address function. All of the complex logic in here does indeed need to happen, but the app.js file doesn't need to worry about it. App.js has a very, very simple if statement that checks if there's an error, and if there is, we print a message. If there's not, great, we move on. The same thing is going to be true with promises. Inside of here, we're going to do anything we need to do that's going to be involved with that asynchronous action. This callback function, it is going to get called with two arguments, resolve and reject. And this is how we're going to manage the state of our promise. When you make a promise, you're making a promise. You're saying, hey, I'm going to go off and I'm going to fetch that website data for you. Now, this could go well, in which case you would resolve the promise, setting its state to fulfilled. When a promise is fulfilled, it's gone out and it's done the thing you've expected it to do. That could be a database request, an HTTP request, or something else completely. Now, when you call reject, you're saying, hey, we tried to get that thing done, man, but we just could not. So the promise has been considered rejected. Those are the two states that you can set a promise to, fulfilled or rejected. Just like inside of geocode.js, we either provide one argument for an error or we provide that second argument if things went well. Instead of doing that, though, promises give us two functions we can call. Now, in order to illustrate exactly how we can use these, we're going to go ahead and call resolve. Once again, this is not asynchronous. We're not doing anything quite yet. So all of this is going to happen in essentially real time as far as you see in the terminal. We're going to call resolve with some data. In this case, I'm going to pass in a string. Hey, it worked. Now this string, this is the value the promise was fulfilled with. This is exactly what someone is going to get back. In our case, it could be the data, whether it's the results or the error message. In our case, though, we're using resolve, so this is going to be the actual data the user wanted. When things go well, this is what they expected. Now, you can only pass one argument to both resolve and reject, which means if you want to provide multiple pieces of information, I recommend resolving or rejecting an object that you can set multiple properties on. In our case, though, a simple message, hey, it worked, will do the job. Now, in order to actually do something when the promise gets either resolved or rejected, we need to call a promise method called then. Some promise dot then. Then lets us provide callback functions for both success cases and error cases. And this is one of the areas that callbacks differ from promises. In a callback, we had one function that fired no matter what, and the arguments let us know whether or not things went well. In promises, we're going to have two functions, and that is going to be what determines whether or not things went as planned. Now, before we dive into adding two functions, let's start with just one. Right here, I'm going to call then passing in one function. This function is only going to get called if the promise gets fulfilled, meaning it works as expected. When it does, it's going to get called with the value passed to resolve. In our case, it's a simple message, but it could be something like a user object in the case of a database request. For now, though, we'll stick with message, and we'll print that message to the screen. Right inside of the callback, when the promise gets fulfilled, we're going to call console.log, printing success. And then as a second argument, I'm going to print the actual message variable. And now that we have a very basic promise example in place, let's go ahead and run it from the terminal using nodemon, which we installed in the previous section. Nodemon. Then we're going to go into the playground folder /promise.js. When we do this, right away our app runs and right away we get success. Hey, it worked. As you saw, this happened instantaneously. There was no delay because we haven't done anything asynchronously. Now, when we first explored callbacks, we used setTimeout to simulate a delay, and that's exactly what we're going to do here. Right inside of our function, I'm going to call setTimeout, passing in the two arguments, the function to call after the delay and the delay in milliseconds. I'll go with 2,500, which is 2.5 seconds. Now, after those 2.5 seconds are up, then and only then do we want to resolve the promise. This means that our function, the one we pass into then, this is not going to get called for 2.5 seconds because as we know, this is not going to get called until the promise resolves. I'm going to save the file, which will restart nodemon. Over in the terminal, you can see we have our delay and then success, hey, it worked, prints to the screen. That 2.5 second delay was caused by this setTimeout. And after the delay was up, in this case, it's an artificial delay, but later it'll be a real delay, we're able to resolve with the data. Now, there's a chance that things didn't go well. You have to handle errors inside of your Node applications. In that case, you wouldn't call resolve, you would call reject. Let's go ahead and comment out this resolve line and create a second one where we call reject. I'm going to call reject much the same way I called resolve. You have to pass in one argument, and in this case, a simple error message will do. Unable to fulfill promise. Now, when we call reject, we're telling the promise that it has been rejected, meaning the thing we tried to do did not go well. And currently, we don't have an argument that handles that. As we mentioned, this function only gets called when things go as expected, not when we have errors. If I save the file and rerun it over in the terminal, what we're going to get is a promise that rejects, but we don't have a handler for it, so nothing's going to print to the screen. And this is going to be a pretty big problem. What we need to do is do something with that error message. Maybe we want to alert the user, or we want to try some other code. Here, you can see that nothing printed between the restarting and the exiting. In order to do something with the error, we're going to add a second argument to then. This second argument, this is what lets us handle errors in our promises. This argument is going to get executed and called with that value. In this case, it's our message. I'm going to create an argument called error message right here. Inside of here, we can do something with that. In this case, we'll print it to the screen using console.log, printing error with a colon and a space to add some nice formatting, followed by the actual value that was rejected. Error message. And now that we have this in place, we can go ahead and refresh things by saving the file, and we are going to see our error message over in the terminal because we now have a place for it to do something. In this case, we have a place for it to print the message to the screen. Unable to fulfill promise prints to the screen, which works exactly as expected, and this is fantastic. We now have a promise that can either get resolved or rejected. If it gets resolved, meaning the promise was fulfilled, we have a function that handles that. If it gets rejected, we have a function that handles that as well. And this is one of the reasons I really love promises. You get to provide different functions depending on whether or not the promise got resolved or rejected. This lets you avoid a lot of the complex if statements inside of your code, which we needed to do in app.js. to manage whether or not the actual callback succeeded or failed. Now, inside a promise, it's important to understand that you can only either resolve or reject a promise once. If you resolve a promise, you can't reject it later, and if you resolve it with one value, you can't change your mind at a later point in time. For example, if I have code like this where I resolve first and then I reject, we're going to get our success message printing to the screen, and we're never going to see the error message because, as I just said, you can only do one of those actions once. You can either resolve once or you can reject once. You can't do both, and you can't do either twice. This is another great advantage over callbacks. There's nothing preventing us from accidentally calling the callback function twice. For example, I could have another line right here. This is a more obvious example, but it could easily be hidden inside of complex if-else statements. In this case, our callback function in app.js is indeed going to get called twice, which can cause really big problems for our program. Inside of the promise example, this callback, it is never going to get called twice. No matter how many times you try to call resolve or reject, this function is only going to get fired once. We can prove that right now by calling resolve again. In this case, when I save the file and refresh things, we're going to resolve with our message, hey, it worked, and we're never ever going to have the function fired a second time with no message because, as we said, the promise is already resolved. Once you set a promise's state to either fulfilled or rejected, you can't set it again. Now, before a promise's resolve or reject function gets called, a promise is in a state which is known as pending, meaning that you're waiting for information to come back or you're waiting for your async computation to finish. In our case, while we're waiting for that weather data to come back, the promise would be considered pending. And a promise is considered settled when it has been either fulfilled or rejected. No matter which one you chose, you could say the promise has settled, meaning that it's no longer pending. In our case, this would be a settled promise that was indeed fulfilled because resolve is called right here. So those are just a couple of the benefits of promises. You don't have to worry about having callbacks called twice. You can provide multiple functions, one for success handling and one for error handling. It really is a fantastic utility. And now that we've gone through a quick example of how promises work, going over just the very fundamentals, we're going to move on to something slightly more complex, and there'll also be a challenge for you so you can learn how to create your own promises. That is coming up in the next video, so stay tuned. I will see you then.